Let's consider this physics question. The angular dispersion of a prism depends on dash. So this is JAMB 1978 physics question 41. So this question has to do with refraction of light through prism, particularly through triangular prism. So, we have different kinds of prism, but the major one that they are talking about here is triangular prism. And first, this question we have met with it before. This is the same as question 39 of JAMB 1978. So it means the question is repeated twice. It can happen like that in an exam. So now, what are the factors that the dispersion of light depends on when light is passed or when light is incident on a triangular prism? When light is incident on a triangular prism, it will be refracted through the prism and then it will be dispersed on the other end. So let me make a diagram of that. So this is a triangular prism. Let's say this is the surface of triangular prism. So most especially an equilateral triangle, equilateral triangle has angle 60 degree. So 60 degree and also 60 degree. So mind you, it may not be equilateral. It can be another type of triangle. Now, when a light is incident on the triangular prism, it will be refracted through the prism and form a straight line. So normally, the incident ray is supposed to follow this direction. It's supposed to continue like this. But because of refraction, due to the refractive index of the glass, there is a deviation. So there is a refraction that is bent away from the normal. So now, then if you consider extending this line, this angle that we have here will be the angle of incidence. And then this same incident angle that is refracted like this, so when it comes out on the other end, it will emerge on the other end like this, exactly like the incident ray. It emerge out. So now this is what we call the emergent ray. This is the incident ray. Incident ray. Why this is the emergent ray? Why this is the refract? So the refracted ray. This is the refracted ray. Now, if you join this angle with this, if you join a line with this, so there will be an angle here. This angle is known as the deviation. So it's supposed to continue, incident is supposed to continue like this, but it bends away from the normal direction. So, and then the connection between the incident ray and the emergent ray is what we call the deviation. The angle between the incident ray and the emergent ray is known as the deviation. Now, after all this, there are several things that can affect the dispersion of light. As light emerges here, so it will disperse. So especially if it is a white light. So white light will disperse out and form 7 colors. That's Roy-Beef. So that's just like the rainbow color: red, orange, yellow, green, blue, indigo, and violet. So it will disperse out to form, due to the refractive index of each. So sorry, due to the wavelength of each. This has the highest wavelength, followed by this, followed by this, followed by, and violet has the lowest wavelength. And this is the arrangement as the light will be dispersed. So this is known as spectrum, light spectrum. That's white light spectrum. Now, this spectrum that we have, what does it depend on? It actually depends on so many things. So it actually depends on about 4 things. The first one is this angle here. This angle is the prism angle. We call it the prism angle. Secondly, it also depends on the incident angle. This angle that we have here is the incident or angle of incidence. Angle of incidence. So making number 2. So the third one is the material with which the glass is made up of. So the material the glass is made up of. So we get that by the refractive index. So refractive index is also known as index of refraction, making three things now, which is also known as refractive index. So the material the glass is made up of, and so it's what determines the index of refraction. Sometimes some material will create great refraction. So, but most times glass always have 4/3 as its refractive index. So that's the third thing. Making how many things now? 1, 2, 3. Then the last one is the wavelength of the color. So you can see that red has the highest wavelength. So wavelength of color. So red has the highest wavelength. So these are the things that the dispersion of angular dispersion depends on. So now, if you check the option A says the index of refraction only. This cannot be the answer because that's not the only thing. I have listed 4 things now. So let's go for B. The angle of incidence as well as the index of refraction. Let's keep this answer, so we may come back to it. Let's go for C. The angle of incidence only. This can also not be the answer. The next one says the thickness of the prism. This is not even among the factor. Then the next one, the prism angle. Not only the prism angle. This cannot be the answer, but this is the best. B is actually the best answer because it contains 2 things. First, the angle of incidence, which is I, and then the index of refraction, which is the refractive index. Thank you. God bless you.